or decline. I guess we'll kick this off. Got it. Okay, a lot of okays here. Sorry. So I know I don't look like Steve. That's because I had to get some plastic surgery because I accidentally stopped Skynet, and now I'm worried that the computers from the future are going to kill me. So, welcome, good morning, or wherever you happen to be. I will go through this agenda, and then, we'll get to it. So, the obviously the meeting is recorded. It's posted on YouTube later. Here's the agenda. Of course, the welcome. Club business, some notes. We'll talk about some presentation stuff. And the Robothon updates. We'll do the normal round the room virtual thing. Do a short break, and then there's a presentation. I think there's a slide on the presentation. As always, mute your mics unless you're actively sharing something. If you can't hear me, sorry. I tried to set up my phone to actually talk to because my laptop is crazy directional. So anytime I look over here, you can't hear me anymore. So yeah, if you can't hear me, just mention something. I apologize for that. And then, of course, as always, use the Zoom chat to ask any questions or make comments, post links, and that sort of thing, as you guys always do. In club business, Lloyd is hosting these online meetings except for today. And then Steve's gonna continue to schedule their presenters. And of course, as always, if you guys have ideas for presentations, or better yet, you want to present on something, which I really encourage. It's actually really fun talking about things you're working on or passionate about. I know it's a little bit nerve-wracking, but once you do it once or twice, you get a lot of enjoyment out of it, I promise. And we're all a bunch of just amateurs at this anyway, so nobody's gonna give you any grief or anything. But send it off to seattleroboticsociety@gmail.com. If you have any questions about that or want any ideas, you can contact me directly too. My email is chas, CHAS, @snowcomakers.org, which I can share in the chat later if you're interested. Club business. Looks okay, yeah. Steve's still looking for alternate facilitators like myself. So if you're interested, reach out again to the email down below. Past events. Let's see, past events. Well, I'll start with one and I'll see if anybody else has something to share. We don't have a past event, but next weekend is the Pop Can Challenge. It is an SRS Pop Can Challenge, but it's not hosted by the SRS. That one's coming in June. That's coming up soon. But it is next weekend on Saturday at Third Place Commons in Lake Forest Park, which is just north of Seattle if you live in the area. It's really easy to get to, and there's some food there, a bookstore, and yeah, it's going to be a ton of fun. It doesn't cost anything, plenty of seating, super low key. It's not like trying to go downtown Seattle, which can be a challenge sometimes getting parking and everything. It's free parking, so yeah. And even really good access to buses if you're a commuter like that. Any other comments on anything that happened just recently? It sounds like a no. And get my participants up here. All right, so we'll continue on. A few of the local maker spaces. Just ran into one that's in Burien. I know a lot of people here are in the south end, and it's I think it's called The Box. It's not on this list. I just found out about it. I'll mention to get it added, but they're only open I think 3 days a week or something like this, like Tuesday, Wednesday, Saturday, or something like that. But they have a lot of cool toys. And it's part of this Burien business owners group, Discover Burien, I think it's called. Anyways, up north, there's Snowco Makers. Then KCLS has one in Federal Way. Oh, you can see the list here, but all good maker spaces. Some of them are different than others. If you're interested in something particular, I actually know a lot about these maker spaces just because from touring or whatever. So if there's something you're really interested in, I want to learn how to do CAD, maybe ask the question, help you to connect you to the right maker space. Let me get my chat window open here too, just in case there's a question. Sorry, I'm reading this one. Okay, thanks. All right, so let's see. There's electronics and robotics meetup. I wonder what that is. I don't know much about that one, but it looks interesting. Actually, is that come and gone? That's come and gone. Pop can challenge, right? I just mentioned that one. That one's next weekend. Probably the 12 to 1 is when they're going to compete. 10 to noon will be like setup and testing. So it looks like War at PDX in Portland is in March. War Hobby Expo. That's for the great guys. I call them RC cars with weapons, but you know, the war robots. Really cool stuff though. Man, those guys draw a crowd, and they're really cool. The amount of work they put in that hardware is amazing. Robo Games, Robot Combat League, and of course, there's, you know, in June, it's maybe coming up on one of the slides. I forget if I looked or not. We have our the Robothon June event coming up, so that'll. So here's our Robothon committee. The next Robo Magellan Plus is an in-person event. Don't have a date set for that one. Actually, Lloyd, do you mind sharing that information if you have it ready? If
yeah,
not, what it?
I can hop into that one. So the next Robo, we've actually got one. Let me back up a sec. We've actually got one event prior to the Robo Magellan Plus. So we've got a mini Robothon on June 8th. And sorry, Chaz, I might be jumping ahead on the slides here.
No, it's perfect. We'll fine. We'll go. We'll cruise by
Okay.
it. That's right.
So anyway, we've got a mini Robothon on June 8th. This is going to be held at the new Firstwa Fieldhouse in Kent. We're going to do build challenge 1, 2, and 3, mini sumo, and the pop can challenge. So this will be kind of it'll be generally indoor outdoor event at the new Fieldhouse. The Robothon website has been updated. If you have a robot and want to compete, the entry form is all set up. So there's full event details, entry form, maps to the facility. The whole thing is on the Robothon website. So head over there. That's robothon.org. And I'll be sending out some, nag emails from time to time to get people to sign up. We've got 5 robots signed up, I think, so far. So we've got enough to do some stuff. So it's like, okay, let's just get a bunch more people. And after that, in probably September, late September, early August, or September, early October, we're going to do another Robo Magellan Plus, just like we did last year at the Sunnycrest Elementary School. That'll be an in-person, fully outdoor event, and it'll basically be mostly a repeat of what we did last year. So that's what we've got coming up for competitions this year.
Yeah, I also encourage you guys to show up for those events, but if you have if you have some of even the most basic of skills, that Robot Challenge 1, if you haven't looked at it, I think you could build a robot for under $20 and actually probably win that competition. So money shouldn't be a barrier there, unless $20 is rough on you. But certainly, I think it could be something somebody could do. So just if you're just getting into it, there's absolutely opportunity. You don't have to be some pro style. Not that any of us are roboticist. That's the official word, I think, right? Roboticist. But certainly, it's a great entry point, and it's a ton of fun. Thank you for sharing.
Thanks, Chaz.
Oh yeah. So soliciting presenters again, right? So as I'd mentioned, definitely looking to fill up the rest of the year for the presenters. I probably owe one in there somewhere. It is a ton of fun, but as it says here, check the time zone of the presenter if there is one. Include if you're interested. If you are recommending somebody, include their information so that we can contact them, and consider presenting one of your own, right? It could just be a project. It could be a portion of a project. It could be a process of your project, whatever. You know, we're all interested in you know, somehow creating, right, making these things, building them, or just any facets of robotics. So there's also the opportunity of leading facilitated topic discussions. Doing that today, but I think I'll save that because I think there's a screen on that. Open discussion forums, right? These are all things that you might be able to sit there and present on, talk about if you have an interest in. Maybe you have some videos you can throw together, or like a Q&A board, that sort of thing. So here's the presentation plan for this year. Today we're going to talk about bio-inspired robotics featuring Festo videos. It's something that I'm presenting for Steve. I think Steve put it all together. I think if it was you, like, claim to it, but I only watched half of it because I wanted to leave some of the fun for so you too, buddy. Sorry. So yeah, it's I haven't watched it all. It looks very interesting, so we'll see how that goes. Bob Cook will present more of his Robo Magellan robot. His last one was amazing. I watched it on YouTube. Very good stuff. Inspired me to actually kind of hurt my feelings because he'd already tried some stuff I had planned on too. And I was like, oh man, I already wasted money spending some money on it, but it was awesome. I learned a lot from it. It's great. Lloyd, you're doing is that CUDA programming? CUDA?
Yeah, so that's CUDA, and that for people who don't know what CUDA is, it's basically I'll show how to take a fairly simple loop with data processing and move it onto the GPU to really speed it up.
Oh,
so that's what CUDA is about. It's programming on the GPU.
Right on.
And there's a lot of depth, but there's actually a pretty simple path to get in. So that's the focus.
Awesome, love it. That is actually was my biggest challenge getting into robotics, was the programming, and doing that sort of stuff really opens up a world of now I can take it to the next step. Camp Peavy's hosting Homebrew Robotics. I don't know what that is, but I look forward to it. You see June and July are open, August as well. The barn has something that they have open, and there's a whole bunch of opens in there. So please consider reaching out again if you have any suggestions, or if you want somebody to look at your presentation to see any suggestions or whatever. I'm happy to help out. I'm sure Lloyd is, everybody. I mentioned this. This is what we're going to talk about here in a little bit. These bio-inspired Festo robots. They're very interesting. We'll have a post-meeting general robotics discussion. It's not recorded, so if there's I don't have a ton of time after this, but I'm happy to sit around. I can stop the share and just pass the buck off to somebody else, but I'll stick around for that a little bit. All right, so I guess we're on to the round the web portion. So of course, Steve is very proactive and threw a bunch of videos in here for me to present if there's not much going on out there, but I do encourage you to come off mute and tell us what's going on, or do you have something to share, or do you have a question? I believe in pregnant pauses, so I'm gonna wait. Nothing out of James.
Recent advances with AI, where they're doing movies now, and also the really cool build where the guy put together the what's it called, GLaDOS from Portal 1. I'll look up those videos. You can throw them on there if you decide you need more video.
Yeah, that's great. Absolutely. I have not seen that. For the very first, I understand that they can take a lot of likeness from people and then use them in movies now, which is I don't know if that's the right thing to do or not. I mean, I guess if they're paying or they license somebody's likeness in movies, but it's very interesting that you could bring people that are no longer with us back to life. Um, the ethics on that one's kind of shaky, I think.
The ones that
Hmm.
they just came out with OpenAI, it's you put in, you know how in the past you could put in like a paragraph or a sentence or something, and it would make a picture, a still picture from it, right? And they started off with like like pictures had 10 fingers, and
Hmm.
people would have an extra head behind their backpack or something,
Yeah.
and then now it's gotten to the point where it's pretty good. Well, what they just came out with was you give it a paragraph and it will generate like up to a 20-second long movie clip where the motion is consistent and clean. They used to have a problem where it would basically be generating a series of images and it would kind of morph from one image to the next. And so you would get stuff like, the person's facial expression or their face would change slightly from frame to frame. Well, now they are absolutely consistent from frame to frame, and the motion is detailed and clean. It is stunning. So, um, your next movie, well, a couple of things. First off, your next movie will probably be generated by an AI. A lot of it will be generated by an AI as opposed to just a few parts. Um, and then secondly, you're going to see movies showing up on YouTube or whatever that were made by anybody, um, and they'll be photorealistic, higher resolution. They will look absolutely like a real shot sequence, but they'll be just some kid in his bedroom or some political party or some state agent, or you're going to see stuff that is stunning and not real. So hang on to your hats, guys. It's going to get wild.
Hmm. Yeah, actually, it's interesting. I work for a global 500 company, um, and I feel motivated, and actually, I feel like there's the startings of suggestions to build a lot of these like machine learning processes and tools into like our day-to-day lives. As a matter of fact, I've recently I built a safety a safety culture in some of these companies. In our company, we have to do a safety presentation at the beginning of any larger meeting, right? You got a number of whatever, 30, 50, whatever plus people. You have to have a safety discussion. Um, and it's like, oh great, I got yet another PowerPoint. But there's a couple tools I knew now that I can just put in, a couple suggestions into the machine learning, and it'll generate an entire PowerPoint for me with a lot of text in the notes for you to have a presentation on anything. And I actually had one that was, basically on a photo harvesting on social media where you can take an image, feed it into one of these, I can't remember the website, but you feed it into this website and it tells you where the image was taken, not just off the metadata, but off the background imagery. And I took one where I showed him that it was scraped off of Facebook, so it didn't have any metadata in it anymore because Facebook actually does a decent job of scraping your personal information on the videos. But with this website, it could still tell that I lived in Everett, right? It knew it based off, I'm guessing, Google car imagery or something like that. But I think we're going to get to the point, James, where if you're a person not using these tools, you're not going to be as productive as the other people that you're basically competing with for, the next level in your career or just, continued work. So I think if you're not using these tools, you should at least start paying attention to them because you're going to be competing with 20 and 30-year-olds that are using the tools and they're going to be a lot more productive.
100%. 100%. The article that I was just reading yesterday was saying that people who are using Copilot, which is the one that's trained off of GitHub,
Yeah.
they're 10 times more productive on average than programmers who aren't. The thing with those is they call it a hallucination, where it will write code that doesn't actually do what you told it to do, right? So you have to test the code, right, in order to make sure it works. And it strikes me that how many years you've probably seen this. How many years have they been telling us to write test code first, write a program that tests the program, and then write the program to the test, right?
Yeah.
So now the key here is you don't have to write the program at all. If you write the test program, and you can get, Copilot or whatever to help you with that, you just write the test program. And then you just write a little script that says, sends the text prompt to CodePilot, or Copilot rather, gets a response back, and then runs it through your test fixture, your test system. And if it passes, you're done. And if it doesn't, then it sends it back and says, no, it failed, with this error, right? And it'll correct it and send you another copy. So you can kind of automatically hold its feet to the fire to get the code. And so in cases where the test harness is less complicated than the code is, that's a fantastic win right there, not even counting the fact that, Copilot will help you write the test fixture. You just have to make sure that the test fixture actually does what you want it to do yourself, right? You can't test that automatically, but you can test the code automatically. So the point I'm trying to make here is, we know that code written to pass a test is generally better code, right? In other words, if you take the time to write the test code that instantiates the specification for your program, then the code that is going to get written is known to pass the test and is therefore better than the code that you just wrote because you think it works, right?
Mm-hmm.
So my expectation is that not only is programmer productivity going to go way up, not only are there therefore going to be fewer entry-level jobs in programming, but also code quality is going to go up at the same time that the cost of getting new code made goes down. So, for society as a whole, I think it's a huge win. For the programming profession, I'm not sure it's a win. For new kids who want to someday dream of owning a van, because they ain't dreaming of owning a house, it's pretty much a disaster.
Well, I mean, there's only so many humans that can do this, thankfully. I mean, I know in our own teams, you wish you could get that coder, but somebody willing to spend more money is going to get them. So I think they're going to end up having to work in whatever you want to call it, a third tier programming, group or something, where they just can't afford the $500,000 program, or they're going to have to deal with the newer people that they're going to pull out of some school of engineering. But I completely understand what you're talking about, and I honestly don't believe it's just programmers. Just like in 30 years ago, we weren't using cell phones, right? We used telephones and we had pagers in, but I mean, just the regular day-to-day business people with MBAs and stuff are having to use like Copilot, right? Copilot's built into Edge and Windows. Now, if yours was updated anyways. And I mean, just for your everyday business tools, I think it's gone past programmers and it's gone into the people that are, program managers or business development leaders or whatever, where, if you want to be quick about it, you don't have to just use it for code. You can help it write letters or correspondence of any kind, that sort of thing. So. We got a thumbs up. All right. So.
Yeah, the whole thing kind of leaves me speechless, which is a strange place for me to be. Getting me to shut up is usually the trick. And I'm just, I mean, I think I understand it, and I'm just completely blown away by it. I mean, it's just the advances in the last few months have just knocked my socks off. So
yeah,
it's a brave new world.
So I'm with you. Actually, I have something to share. So, I think one of the big breakthroughs, I picked electronics used to be my hobby, right? Like my day to day. If you said, "Hey, Chas, what's your hobby?" I would have said electronics, and it definitely has switched to robotics. And I think the reason my hobby switched to robotics is because I felt like it was things that I could keep pushing myself to learn other things besides electronics, which is important. And matter of fact, I think electronics is a hobby, and I imagine, James, you can understand this one. I feel like it was a hobby that was, you know, I guess going away slowly, there wasn't as many people into robotics until the Arduino, right? When the Arduino came out, it put microcontrollers into the hands of anybody, right? 8-year-old kids can write some code. And anyways, so, the hobby came a boom, and with that, many other things along the lines, the ready access to hobby grade computing systems. Well, um, I built these, like one of the first robots, um, I got and reached out by Mark, and I hadn't built anything I'd consider, a robot other than just playing around, prior to participating in the PopCan challenge. And Mark, the developer, creator of it, reached out and he's like, "Hey, would you want to build a robot with me?" Because I was leading a group up north. And I said yes. And my first year, it was this big kludge of aluminum. But anyways, um, the number one thing that really helped me like expand and start building robots, I felt like, yeah, this is a ton of fun, was being able to actually create new things with CAD. And I always thought of 3D printing as kind of a gimmick. And this right here, actually, this little piece here is my very first 3D print, that I designed myself. I actually built it in CAD, and I know it's just a cheesy little bracket, but I needed 2 of these for bumpers, and I didn't want to cut them out of aluminum and drill them and all that stuff. And I did some CAD, right? I CAD'd them up. It looks simple. It was simple, but I was happy. I could export it. I could slice it and then 3D print it, and it was mine. I was like, yes, a custom piece of robotics. And since like the power of these things lead to, this is an unfinished piece, but here's an example of something that I kind of recently did. And this is just a case, right? It's a case with a microcontroller inside of it still, and has a little display and a little rotary, well, the rotary coder's not in it right now, and a little, has one of those NRF radios in it. So it, but yeah, it's part of like a bigger piece that I'm building for my Dead Man Switch. But just like, like when I'm building robots now, it's like this whole like parts and pieces. I actually design my entire robot in CAD now. Not all the nuts and bolts, which sometimes is a problem, and I run into issues. But like all these little like servo attachments and everything. You guys have probably seen James Bruton. I think that's his name, out of England. I'm guessing it's British accent. But he 3D prints all these things for his robots, and I sit there and think, oh, some of it isn't the most reliable stuff. It's only going to last, but I mean, how much do you really run your robot around, even in competition? Like, a couple dozen hours before the competition, and maybe an hour or 2 of front time during a competition. And really, even if it breaks, it's so cheap and easy to print this. I mean, this is a sub penny part, right? That, and while not crazy impressive, you could have done this out of aluminum, you could have machined it, but I took 5 minutes to put this on CAD and then print it. So I would encourage you to actually learn how to use CAD, and there's a lot of free opportunities. There's Fusion 360. I'm actually doing a presentation during the next Snowco Makerspace Robotics Club after that on how to use Onshape for just starting out, because Onshape is a free CAD. It's free for people that are just hobbyists, just getting started with it. But I feel like if you're interested, even if it's outside of robotics, it just helps you take your concept instead of drawing it all out and measuring it, which is important. But you can design so much faster in CAD once you start getting used to it. It's a ton of fun. It's very fun to be able to see like your concept come to shape and then realize, oh, that would not work out because when it rotates, it hits something and that sort of thing. So if you are ever interested in that, I could actually probably do like a 1-hour talk on it in one of these meetings if you guys are interested in that sort of thing.
If you're interested, I do a talk on how G-code works. So it's sort of like the assembly language of 3D printing, if you will.
Yeah, absolutely.
That would be cool.
Yeah.
I just feel like you should learn assembly language before you learn C, and then you can write code in some stupid language. But like if you actually understand how G code works, it kind of makes the whole thing more sense. And if you think about it, 3D printer is nothing more than a robot, and a robot is programmed with some command language. There are a series of commands that the robot knows how to do, and G code are the commands that the robot knows how to do. So think about it this way: if you know how to write G code by hand, you're not dependent on a slicer or using the 3D printer to print 3D printed parts. You can then use the 3D printer to pick and place components or build things from parts that it has just 3D printed. There's a couple of great videos of a guy who he 3D prints a bunch of jigs and parts and then uses hand-coded G-code to run the printer so that it picks up the jigs and tools and uses those to take the parts and build a race car. It puts this little car together from the parts that it 3D printed using tools and jigs that it just 3D printed. So it's literally like a complete assembly robot, which I've always thought that was just stunning. I really recommend it. So, yeah.
Yeah. Yeah, that would be amazing if you were interested in that. I do think you're right. 3D printers are robots, and CNC machines are robots as well, and definitely could be applicable. You mentioned, before I mention it, Robert, thank you for dropping that note about the Northwest Model Hobby Expo into the chat. That's coming up. I can't remember. It's like April, I suppose. The link's there for you to look at it, but it's really interesting to see all the model hobby stuff, like it's boats and planes and quadcopters and all sorts. And there's a bunch of like demos. I actually think usually Ward has something there as well, some robotic stuff in the back corner, which is pretty cool. April 12th, 13th, and 14th. Thanks. You mentioned assembly. I couldn't agree more with you. This is what I learned how to program on. This is an elf.
Oh my God, that's a cosmic elf.
Yeah,
that's what I started with. That's
really?
My very first, literally the first thing I made. It was 256 whole bytes of RAM, not K, not M, not G, 256 bytes. And I got a 4K static RAM board for it. And I was like, how am I ever going to fill an entire 4K static RAM board? Which, as it turned out, didn't really matter because the thing generated so much heat that I couldn't keep it cooled down. You had to have a fan running on it at all times or it would literally unsolder itself.
Oh my gosh.
So, yeah, it was amazing.
That's cool.
That's so cool. So many people started with something like that, and that's just neat to see.
Yeah,
I also. Oh, sorry.
Oh no, go ahead.
Oh, I was gonna say I also had an elf.
You did? It's awesome.
Myself. Yep, it was an 1802 Cosmic Elf or something like that.
Yeah, CDP 1802 and RCA processor. Yeah.
Yep, and typed everything in by hand, and yep, that's one of the things I had as a kid and started on. I haven't heard that term for that system in decades.
And we thought we were really fancy because we had the hexadecimal keypad. All those other poor bastards had to deal with that row of switches and the light, and we could type in stuff fast.
For no 16 switches for me. Yeah,
that's it, Chaz. Yep, I don't have mine anymore. Kudos for hanging on to that. I kind of wish I did now, but
you know how it is.
That was my introduction to robotics because my dad and I designed a transistor driver for DC motors 2-channel and a relay driver and hooked it up to the ELF, and we built a robot that could drive around the room and had little bumpers to detect when it run into something. And basically it was one motor turned the front steering wheel, and then the front steering wheel also had a motor in it. So it was the drive motor and steering on one wheel, and then the other two were just followers. And it was an H bridge for the steering motor, and then just a front drive for the drive motor with a relay to reverse it. And so we figured out a few things, like you could power up the drive motor and then unpower it. It would coast to a stop. But if you turned off the power to the drive motor and flipped the relay into reverse, then it would back generate and it would come to an instantaneous stop. It would like slam to a stop. And then the other thing I figured out was that if I was going to run a program, I could vibrate the relay to make a buzzing sound to be a warning to people that the robot was about to move. The stuff that I learned from that was just, it was endless. So cool. So, oh yeah, there was a pot that told me the position of the rotation of the drive motor, the steering.
Oh yeah, feedback.
Right. And I had to write a sigma delta A to D converter that the Cosmic Elf would run, because I had a DAC, right? I had an R2R DAC, and then I could put out a voltage, and then I had a comparator, and then I did this sigma delta in order to figure out what the voltage was on the pot, in order to figure out whether I should drive the motor left or right in order to get into the right position. And debugging that was like a week for a kid, right?
Yeah.
That was my big accomplishment. Actually, I think it was a month, to be honest with you.
I don't doubt that at all. I remember, so like you, I started in assembly and, just manually typing them in and figuring it out. I did end up, somebody gifted me a video card for it that I never got running for it. Still have that too. But, it meant so much to me that I kept all that stuff. There's a lot of stuff I've gotten rid of. I wish I kept, but those I kept that. But then I started with those PIC 16F, like 8-bit microcontrollers before Arduino, right?
Mm-hmm.
And they came out the flash variants, which is great because you could program and reprogram, which is really nice. no UV anymore. And yeah, it was amazing, like how much you're sitting there, and heck, I maybe it's habit, but I still every once in a while troubleshoot by sending blink codes to an LED. Like, is it making it here? What's going on here? Like, why is this not working? And, did it make it through the loop? That's usually the question. Like, how come it's not going? Did it make it through this loop? Did it make it through that loop? But yeah, and now like in these Arduinos, it's so nice. Actually, I came to the realization that my very first PopCan challenge was with these 8-bit PIC microcontrollers. And I showed up and I had something that, I'm like, okay, this is all programmed. It's all tested. I'm going to have to do some like timing tweaks or something like that. That's it. And Mark showed up, and this might have been the second one, or I don't remember if it's the second or the first. And he came up and he wasn't even close to done. He's like, oh, I didn't have a lot of time. But he had an Arduino, and he wrote his entire application for his robot while we were there. I thought for sure, I'm like, aha, I won. No, he won. He wrote his entire, all his code sitting there. And I'm like, I gotta learn C because it was all in assembly. And especially when you start dealing with I2C, I'm just like, trying to do that in assembly. Oh my gosh, there's definitely a reason there's higher level languages. But yeah, good for Mark one where they pulled it off. It was gorgeous. I'm like, how in the world did you develop something in 2 hours? When it took me months to get mine done. But yeah.
So I'll take it to the next step. So I've been doing a fair amount of Rust programming over the last few years, and it's I don't know how many people have messed with it, but the language itself is somewhat like C and C++, but it's got more constraints on what you can do, and it's got a very advanced linter built in. And so what you find is it's also got a helper built in as well that'll not just give you IntelliSense, but it'll suggest code changes. It's fairly simple stuff for style or so forth. But the sense is it becomes much more of a dialogue with the compiler. So you've got the typical edit compile run type of thing.
Mm-hmm.
That in Rust, if you're running the language server, which gives you all these hints and tools and stuff. If you're running that in your editor, and most modern editors support that plugin, it's you're editing every time you save, or depending on how the editor works, sometimes in real time, it's popping hints up to you. So your edit becomes much more of a dialogue and a collaboration with the compiler, because the compiler is running in the background. When you go to compile, generally, if you can get it to compile, it's going to work. And then your debug step becomes much, much reduced. So it takes longer to write initially, although not too bad. And then your debugging is gone. It's a, and this isn't even an AI type of thing. This is just the advancing compiler technology. One of the guys there's a Rust group, that thing that really impressed me was the optimization technology. This thing's built on top of LLVM, if you're familiar with that at all. But he was actually getting the thing to run on a Commodore 64. So he was building Rust code for a Commodore 64. And he built, it was probably 200 to 500 lines of code, right? And he built it all as libraries and so forth, right? So he had a full library to reach out and grab the joystick, process the input from the joystick, and then on the Commodore 64, if you folks remember, you could update the frame color, right, on the video display. And basically, you just had a statement to grab onto that, and then if the button was pressed, the frame color was red. If it wasn't, it was blue, or something on that order. Really, really simple. And you're looking at all this code, and then you gave it to the compiler, and then he looked at it took him a little bit to get this optimized, but he then looked at the assembly instructions, and it was 3 assembly instructions. Read the bit, read the bit that's on the joystick button, fit that bit to the, update the display, and jump back to the beginning. And it was impressive as hell to see. Normally, you write these things that are highly abstracted and designed as libraries and all that. And you take a lot of overhead for it. And so you had a very easy to understand, very readable, very well written code base, and the compiler turned it into 3 assembly instructions. So you paid nothing for all that maintainability and readability and so forth. And that was really impressive.
Yeah, no joke. Yeah, and of course, one of those advantages of assembly is those is the small size of the applications. And now, whenever I like anybody else use these libraries, are like, oh, that was quite the bit of hit in RAM, because you pay for all these features and stuff that some of them don't get baked in, but many of them do, that you're not necessarily using when it compiles. But that's pretty awesome.
Yeah, I wish they don't videotape their meetings. I wish they're starting to. I kind of was razzing them about it, so they're starting to. But I wish you would have had that videotaped. That was just like, wow, because that's in the C++ community, that's that's kind of one of their pushes now, is to get all these high level abstractions and stuff and make sure they're really coming down to something that a human cannot beat by doing assembler. And they're pretty good at it, but that was a beautiful example of it.
When you guys are dealing with your programming, of course, I don't know what level they're programming C++ in, but I recently ran into something, and you're probably the guy I would have asked this if I had thought about it. How do they handle things like multi-core processors? Because those are coming to the embedded world.
Mm-hmm.
Like, is that something that you have to actively consider when you're programming this? I don't program that high level.
Yeah, so I'm assuming that statement was directed at me.
Yeah.
Okay, I wasn't sure if you were somebody else knows more about it than I do. Feel free. So if you're on a desktop, traditionally you don't worry about it. You just you work in high level abstractions that are like processes and threads, and you got this whole selection of, there's green threads and thread pools and asynchronous programming. You're working in these very high level abstractions. You pretty much leave it to the operating system to just go deal with it, right? Um, the latest processors that are coming out of Intel, they've taken on this, and some of the ARM processors have the, matter of fact, matter of fact, all, I think, of the modern ARM processors that are multi-core have this big little concept. So you have a big complex core that's really fast and really power hungry, and you fire that up when you need it, and then you have this little ARM core, or this little core, not necessarily ARM, it's x86 as well, and it's a much lighter core. So and for instance, in the Intel world, the complex core is like an i7 or an i9 core. That's state of the art. It's hyper threaded, the whole thing. And then the little core is something more like, I don't know what it is. It's like a Celeron or something. It's modern, but it's a simpler core. It's not hyper threaded. It doesn't necessarily have all the vectorization instructions and so forth. So if you're just writing general code, again, you don't have to pay any attention to it. If you're going to start writing code that does use these things, I'm not sure how you do that. That's actually something I'd like to find out. The last processor I just got the AMD that's still has all the big cores on it. I do that stuff, and I just simply ignore the architecture underneath. I assume my entire processor is homogeneous. In the cases like the BeagleBone Black, for instance, so that's the only one I've peripherally dealt with. You have a large ARM core, and I don't remember which one, but then it's an A series ARM core, so an application level processor. And the BeagleBone Black, for instance, has two ARM M cores on it, if I remember properly. What you essentially do is you write, or at least the way it was done when I was working on these, is you write essentially a program for the application processor, and you do that just like you would, and it's a multi-threaded processor. And then you write another program for the M core, or the little embedded real-time processor. On that thing, the application processor is running Linux. The M core is just running nothing, right? It's bare metal. So you write one Linux application, you write a second bare metal program, and then by one mechanism or another, and I don't remember how this works, you embed the M series code or the M processor code into the application, download the whole thing, and when the application starts up, it downloads the real-time or little M core code to that processor. So it's kind of the whole gambit depending on what you're doing. A desktop, if it's heterogeneous, homogeneous, you just write and you just don't care what happens. The OS handles it for you. In the middle, you might care on the desktop, and on a BeagleBone, at least in that particular case, you have to do it yourself.
Okay. Yeah, I thought I was missing something where it seemed like there isn't. Okay, I'll explain where I'm coming from. So I recently switched my Ken Challenge robot, which is actually behind me on the ground, to our RP 2040s because it was a board that had built-on CAN, and I didn't have to add the CAN interface onto it. That's lazy, I know, but it also has just a stupid amount of memory on it. But program memory and RAM. And so here's another RP 2040 board that Adafruit came out. Where are you at? 2040 came out, and it's just this little processor. Adafruit, they make these cute little processors. The same kind of thing I have, except for this one is a USB host instead of having a CAN interface on it. But they're dual core, and I was looking at it, and I've used I don't have it set up. I've used Visual Studio code to write my code in the past, but right now I just, on my Mac, I've just been using the Arduino IDE. And the idea is you actually write 2 loops. And so you have 2 separate loops that you run, which is interesting in Arduino to do that because, Arduino's, it's a hobbyist IDE. It's not like MP or any of the other ones. But it's still a super fun IDE to use for small stuff. But yeah, I just found it interesting. And it's actually really nice in robotics because if you don't know about this in robotics, you do, Lloyd, but some of the others might not. Sensors take a long time to interface with, right? You're sitting there, you tell them to do something. Even if you can come back and say, okay, do you have data ready? No. That whole interfacing takes up a lot of time sometimes. Particularly like the IMUs take a long time. And yeah, you could do stuff in between, but it still takes a lot of time for them to like hand back off and say, yeah, okay, I'll let you know when I got some data or something. And some of them are better than others. Some sensors are others. And some of those, like if you're trying to of course, in programming, you try to start something and then on the next loop, you're like, hey, are you done yet? Or you use like some sort of timer and like, hey, is the timer up? Now I should check on this. Still, you want to do that so you can use all those free cycles to do everything else, right? Like I barely have a delay one in my code where possible. But yeah, it's so nice to be able to, and I haven't done it yet, to offload all these functions onto the second core that are kind of slow and not very time dependent, where I can run a core that is very, strict about, limiting the delays as much as possible. So I was just wondering like how it worked and if what I was diving into was kind of the right direction. So but I don't know that there's not a lot of, I haven't seen a lot of articles yet about people using both cores on their Arduino projects, the RP2040, sorry. But they are really cool little processes. And man, it is just shocking how cheap these things are. I don't know how they do it. Of course, you can say that about anything, ESP32s or whatever. But I just remember like dev boards costing, $200 before. And that's in the 90s. And now, like, this is like $18 or something. It's just bonkers.
I was at one point I was happy to get a dev board for $200.
Fair enough. For sure. Yeah.
Although we have gotten past the point where they were giving them away for a while. Renesas and Microchip and TI had the MSP 430s they were selling for $4.30 for a while.
Yeah. That's yeah, and I think they were doing that because everybody buying them were developers that were building them for projects. But now there's the hobbyists. You buy one of these, and I'm not going to put this in a product. This is just for fun for me. So yeah, they can't get away from. That's like I don't have any in here, but the old data books, right? Like you call it Motorola or National or something, and you have a giant book of their product line and. Yeah, they don't do that anymore either. So they don't need to PDFs. But
I was happy to get rid of the data books. I don't have room for that.
Me too. The only ones I kept were the CDP 1802 books, and I think I have a x86 book or something just for fun. Yeah. So those don't get cracked open. But cool. Well, thanks for that information about the dual core programming. I was kind of curious how people did it. I do remember. I think it was like one of the Intel like Galileos or something like that of doing something along the lines of how the BeagleBone was done. I didn't know if things had come along to be any different and if I was missing it. It's really weird transitioning from programming at like, bare metal right on the chip to like coming from the other direction and how they meet in the middle. It doesn't seem like it's very standardized at all or anything. Okay, well, awesome. Thanks, guys. We are kind of at the time where it's break time, so feel free to keep chatting or whatever. I am going to go use this moment to go drink a little bit of coffee, but we'll come back at, I don't know, it says 11:05, which is 10 minutes. Maybe I'll get it prepared just a little bit earlier than that, but and start right at it. So, yeah, go get a coffee refill. We'll do this Festo robotics presentation. James, are you on? Are you back?
Yeah, I'm here.
Okay. So, in true tradition for the PopCan Challenge robots up here, I rebuilt my robot. I rebuilt it smaller with the intention of building it so that because I travel for work more than I'd like, it would fit in a suitcase, right? The old one definitely could not. So, oops, sorry about that, robot. So it's just the size that it would fit, well packed into, the LiPo battery might be a little bit of an issue, but whatever. I can bring that in to carry on. But I'd had an idea for a grabber, right? Something has to grab the pop can. And that's always been a challenge for me. Like I've always had some ideas on it. I think both the people that have robots that can grab cans, their arms, right? They can grab something. They have like cans. And that seems too I don't want to do the same thing as them, right? Like that's awesome. They won the the race to be able to do that. I feel compelled to do something different. So
Push the envelope, always.
yeah, exactly, right? I mean, the whole purpose of this hobby for me is like learn how to do something different, even if it's dumb. And I built the cheesiest thing ever, but it is so rewarding to play with it. I built this little accordion arm guy. And so, it's driven by a little linear actuator to and I think it'll squeeze up and just fit inside my robot, not 100% sure. And of course, this is just like the demo with all the markup on things I have to change about it. But
And then the mounting plate is you're going to put some kind of a gripper on that blue mounting plate. Yeah.
Yeah, and that actually a gripper. I'm going to lasso it. So I have I don't think it's in here, but
Oh, cool. What a great idea, lassoing it. I love it.
Basically, I'm going to come over it and then just have a piece of TPU belt, like tighten up against it. So it's just the servo is going to rotate the belt tighter. And so I'm kind of lassoing the can into a grip.
You know what you could do there? Well, I don't know if, maybe it wouldn't work. I was going to say what you could use is use a large zip tie, but instead of using the little ratchet mechanism, have that actuated by the servo. I'm not sure how. Well, no, that should work okay as long as you can get as long as you can 3D print something fine enough to engage with the deal. But I'm looking at like the really big zip ties have a fairly large.
Yeah, they have a lot of chunk to them. Yeah, that is possible. I just 3D printed a piece of TPU belt.
Because Chaz, I have to say, okay, look, I think it's totally cool that you're using 3D printers. I think that's excellent. All right. But, at some point in time, all my friends who start using 3D printers, there has to be like an intervention where it's like, okay, just because you can now 3D print, that doesn't mean you should. That everything has to be 3D printed anymore. But no, I'm just poking fun at you, buddy. That's there's nothing wrong.
You're not wrong. I do sometimes, what is the saying, like, if you have a hammer, all you see is nails.
That's it. That's
right.
It.
So you're not wrong, and I definitely am always looking for something. I fight it, and I understand because it is so like, I built it in CAD, so it's there, so I can print it. But to your point, like actually the first TPU belt did fail because it's still printed and it failed because it's just not quite the right material. It was just test number one. But there is actually a lot of different things like, I want something with a little bit of, I don't know, something with a little bit of grip, right? Because I want, relying on the belt to have friction to hold on to it. So
I was just thinking it's too bad that there isn't a magnet or a that there isn't anything like that attracts liquid. Why isn't there something that just attracts liquid in the world? I constantly complain about the design of our universe.
Yeah.
Like, what were they thinking? The kid who coded this simulation for his homework was obviously phoning it in. So the other one is vacuum, but the problem with vacuum is, don't ask me how I know this. It gets first off, you have to be able to suck and blow, because if you only suck, then you get clogged up. No matter what you do, you get stuff into the vacuum area, and then you have to have a surface that's really soft.
Sort of like an egg. There are certain.
Sort of like a what? I didn't hear what was said.
Yeah, Paul, what was that?
Oh, sorry, my mic's on. I was talking to somebody.
Okay. No worries at all. So yeah, there's just so many things. So then you have to be able to blow in order to blow the dirt back out of it. So suction cups are a pain. It has to be soft so it will mold to the surface, but at the same time it has to be stiff so it can lift the thing. So that's a really difficult combination. One of the things I'm kind of curious to see is they're starting to come out with multi-material 3D printers. So I'm feeding your addiction here. Yeah, if you can get something that has if you print I don't know, thin nylon as the stiff part and TPU as the soft part, it feels like you ought to be able to print sort of like tree supports, but as a 3D printed suction cup that would mold itself around an object and then pull air through the inside of each one of the tree supports, and the leaves on the end of the tree support would be like the TPU, soft cup. Just throwing ideas out there.
Yeah, so I want to prove to you before I have to switch over here that I am drinking your Kool-Aid a little bit, because this used to be this used to be my 3D printed. It had a servo that sat here, and then it has 3D printed gears with a shaft that it held on to with some bearings, and then my wheel steering mechanism, because I have that's how I steer wheels. Then I switched to non-3D printed. Well, it's attached to a lot of 3D printing, but I switched to I don't know if you can see it.
Yeah,
but,
there you go. See, metal with the 3D printed parts to hold everything, or to
exactly.
Thing. That's the key. Yeah.
I'm
not even going to get into it.
Yeah.
I'm dangerously close to violating NDAs here.
Mhm.
But your approach there is I think the right one. It's not using the plastic for the structural components.
Yeah, exactly. It's like that combination. All right, so I need to share screen here. I need to share with audio.
That's a cool looking robot there, by the way, Chas. You going to do a presentation on that?
Yeah.
That's a good one. I'd like to see more about that. I'd like to see more from Greg. He always builds cool robots, and Dick too. I have to say, Dick, your last was that the pop can challenge where you had to go and get the can of pop out of the refrigerator in the other room?
Yeah.
That was just damned impressive thinking there. I really was jazzed about that, and I'm always curious to see what tweaks people have done to their robots afterwards.
There. I don't know if I'm sharing. Cancel. There's sound. Okay. Oop. Portion of the screen. Optimize. Share. What? Sorry, guys. I thought I had this all figured out on here.
Take your time.
Yeah,
No
almost
stress.
there. It's just like the sharing with the audio optimized for, and it's kind of funny. It's like, you know, all right, so I want to share. Stop share. Share screen. Oh, basic. Maybe I'm just. There we go. Share sound. Share. What in the world? Please restart your audio sharing application immediately. All right, can you guys hear me?
Yeah.
All right, well, let me start the slideshow. I think I got her. Yep, looks like it. Well, that's funny. Why is it? Oh boy, failure. All right, I'm just gonna share on another computer. Mhm. All right, guys. Sorry about that. All right, so. All right, here we are. So bio-inspired robots, only 4 minutes and 32 seconds late. Can somebody hear me just because I had to switch to a different
Yep, we're
computer?
good.
Okay, thank you. All right, so let's move along. We're going to look at some amazing machines that mimic natural creatures for sure. As you watch these videos, think about a couple things, you know. Think about the creatures you're emulating and how realistic do they seem to you. The mechanical sophistication and complexity of those machines, well, you can read here. What impresses you? And one thing that I only watched half this presentation because I wanted to save some of the surprise and ooh and awe for myself as well, because it was impressive. Um, but I'm trying to like place, and maybe this is a opinion, but I have a hard time believing that a company that is trying to make a profit of some sort would spend time developing these things. And I'm trying to figure out like where's the R and you know why did this make sense for R&D? But and so we'll talk about it in between videos and I'll just move forward with the first one. So I'll
For my first assignment, I was sent to Festo in Germany. It's a company known for
Can you
making...
guys hear that?
Yep.
Okay, good. Sorry.
For my first assignment, I was sent to Festo in Germany. It's a company known for making manufacturing robots. Well, that might sound too exciting, but as soon as I arrived, it was clear to see that this was no ordinary engineering firm.
Wow, this place is weird. Oh, look at that weird dome thing.
It's like a Willy Wonka factory of amazing tech. Out front, a herd of robotic lawnmowers munch the grass, and a rather phallic-looking barrier stops traffic at the gates.
I'm easily entertained.
From robotic arms to pneumatic plants and the first pneumatic F1 simulator, this company has spent hours tapping into people's creativity to make cool stuff from electronics.
Do you think I can press this? Will anyone mind?
But the big things here are fish, robotic fish. Festo have something of an obsession with sea life. This manta ray may look real, but spot the company logo. This fish is actually a robot created by Festo's bionic learning network, who believe that by mimicking nature, they'll ultimately be able to make some of the most intelligent, useful robots around. And this theory has led to their latest creation, robotic jellyfish.
So I've come a bit off the beaten track here at Festo, and I'm going to go into the bowels of their research and development area, where they keep all the cool stuff, to meet Marcus, who's the head honcho. Hi, are you Marcus?
Hello, I'm
Hello,
Marcus.
Dallas Campbell. Nice to meet you.
Hello, Dallas.
Thank you very much for letting me come in and have a look at all your good stuff.
Okay.
Marcus was instrumental in the development of the jellyfish.
We have.
Oh, my word.
We like to demonstrate our competence in electronics and also in electric drives.
By building strange robot jellyfish.
Yes.
Fair enough.
I've been told these creatures are intelligent, autonomous robots, but to begin with, I wasn't too sure about the intelligent bit.
It's kind of thinking. Is it on, or is it just sort of? Oh!
Now it's on.
Oh my!
Yeah.
Look at that!
As the jellyfish reach the bottom of the tank, their pressure sensors kick in and tell them to swim up, preventing a crash landing.
Look at that! Oh my word! That is beautiful.
These jellyfish have been built to explore how robots can work together in a group and interact with each other. In addition to pressure sensors, these critters also have light and radio sensors, which allow them to communicate with one another to avoid collisions. They even know when they're low on power and use an in-tank charger to keep themselves alive.
See, here's the thing. I've got a small aquarium at home. If I got one of these, it would dominate it, but it's a small price to pay.
The aqua jellies change direction using a four-way pendulum, and they move through the water using something I learnt about at school, peristaltic motion.
I remember peristaltic motion when you kind of swallow and your throat kind of, you know, contracts and expands, and that's how you get food down there. But I guess a jellyfish, similar principle. So, sorry about it, I'm going to do this. If you're there, you wanted to, it's sort of like that, isn't it? Isn't it?
Yes.
After my fabulous earthworm impression, there was really nowhere for me to go, but I was thrown a lifeline of a simple infrared TV remote control. The jellyfish communicate with each other using infrared. Therefore, when I pressed one of the buttons on the remote, they thought I was one of them.
I think she fancies me. This one, rather than being repelled by me, this one's actually a bit keen.
The really exciting thing is how these jellies work together. Using their sensors, they can prevent collisions, maximize their living space in the tank, and ensure each one gets an equal time at the power charger. Simple stuff, but it could lead to the development of team-working robots that create better products more efficiently. Before I left, there was one more invention to see. Festo have built a similar robot to the aqua jelly, but they've called it the air jelly. Air jelly? Yeah? Do you see where this is going?
Oh, that is wild. That is, oh, that's fantastic.
The air jelly is filled with helium to make it almost weightless. It moves through the air just like the aqua jelly using peristaltic motion. However, it still needs a man to steer it. It has a battery motor and sensor which enables it to be directed using remote control.
Could I try and have a go? Would that be okay? What do you think? I did my cycling proficiency test in England when I was 10, so I'm very good. Should I take over?
Yes.
Okay. Let's go crazy.
Fully power.
So it's not the fastest thing in the world.
Yes, it's good.
Yeah. How's that? Is that good? Yeah.
Yes.
I'm trying to wiggle it over towards me, but it's going the wrong way.
Slowly. Yeah.
Oh God, I've crashed it already.
That's not a problem.
There's anyone in the world have destroyed it. Oh, I love this.
Yeah.
Everyone should have a remote control jellyfish.
So, you know, Steve here poses the questions, you know, the manta rays and other fish-like creatures, you know, what do you think of them? The jellyfish that swims and recharges itself.
So
I
I guess
found it
we need
interesting.
some
go ahead.
really lightweight solar panels. But then the problem with that is you don't want it out in the sun, right? In order to be able to recharge itself. The air one, I mean.
Mhm.
And yeah, it won't survive anything like a significant breeze, like air.
Yeah.
That's not going to happen. But like in a building where if you could get enough light from, you know, interior lighting in a large building, like in an auditorium, just could you imagine coming to work every day and just seeing that thing flapping around in the auditorium and know that like you had some part in building it? I mean, I would just like, you know, what like Google offers, like, you know, stupid stuff like massages and free food, you know. That's what I want to motivate me. Just walk in and see that and go, I made the left knee actuator for that.
Yeah.
And or I wrote 10 lines of code that went into that, and I would just be over the moon.
I'm 100% with you. I think it was, I mean, I was in awe when I saw that the air jelly, just because it is so elegant, so beautiful. Um, and yeah, to have that giant indoor space where you could just see that, you know, if you're trying to impress some investors and you have that thing cruising down there, but yeah, just the pride of knowing that you're part of the team, like on anything that you build is so impressive, but something on so big and elegant, you know, usually I end up building stuff that are very, I mean, I have pride in them, but they're, you know, it's very rigid and structured and, you know, yeah, it turns it on and off at the right time. But something like that is just amazing. I have I have a little bit of a problem, not, you know, like with the helium use, just because, you know, it's not really renewable per se. Um, you know, like it doesn't seem like it's something that you could really keep keep using, and, you know, maybe the hydrogen, but you know, we know what happens with hydrogen. So but I thought it was pretty amazing. Anything else before I go on to the next one? All right. So that bionic wheel was just amazing. I can't even imagine how much time it took to stick all the mechanics into that thing. I mean, it just the density of all the moving parts just blows my mind. I can't even compute how they did that.
Really is amazing.
Yeah, and I also really was crazy impressed, and it makes me wildly jealous that I haven't thought of it. But that arm control thing for the robotic kangaroo was just next level super cool as well. So
There's a lot of stuff in there, like I think Bernardo was talking about, like linkages and mechanisms, and I see a lot of that as what I call mechanical computing, which is very, very, very overlooked. Um, a lot of the stuff that you can do with a linkage or a mechanism or something like that, it's every bit as computationally powerful and and difficult um, as writing code. And there's a lot of that in these robots. A lot of this
yeah,
Yeah.
kind of.
great.
So James, it's interesting you mentioned that, and I'll just throw this out here for a little caveat. So when I was really, really young, like teenager, my friend's father worked for, I can't think of the name of it. They did, they basically did instrumentation for Boeing. So the instrumentation for the aircraft that's on the pilots use, the flight deck. And so he decided, we'll take the kids down and, let them see what a autopilot looks like, right? So, we're thinking, hey, we have to go see this, really fancy computer. So we go in, there's a box. He takes the cover off the box. It was all mechanical. It was
Oh,
so this was a flight computer, for and then basically it was the autopilot for one of, this was 1970s, 1980s, vintage, right? You didn't have electronic systems. All of it was done mechanically. And he was explaining that, it's like, okay, look, the way these wheels are shaped and the gearing, and essentially the mechanical computer carried out the differential equations for managing an autopilot and doing a PID. And, all that was done with mechanics and vacuum and the if my friend and I were initially just appalled. It's like, look, you brought us down here to see a computer, right? And
Yeah,
over the next years, I realized, yeah, that actually is it. It's and much more elegant in some ways than the electronic systems that replaced it. But they also had problems like they wear, and when they wear, they the equations effectively change and stuff like that.
but I think you're going to see a resurgence of that with like MEMS devices and
Yeah,
eventually with nanotechnology as we get to
yep,
that point,
yeah, I
where
agree.
those issues of like wear and stuff like that are not, no longer really an issue, and the extra cost of driving the mechanism is no longer an issue. But there's also places where, like when you have to do something that's a relatively cheap computation, or it's a computation like a derivative that lends itself to mechanization, and you would have to do all the electronics required to encode the input,
Hmm.
do the calculation in code or whatever, and then drive a motor in order to put it back out again, where you could just, put the right linkage from point A to point B, and suddenly you're there.
And yeah, and the takeaway, decade later or more, when I finally got realized what I was really looking at, it's like, look, the algorithm that you build and encode is not necessarily dependent on the medium upon which you build it, right?
Yes,
You can do it
exactly.
mechanical, you can do it with analog, you can do it
Yeah.
with digital, you can do it with optical, you can do it with, in some cases, quantum. It's another dimension to think about when you're designing.
let me just give you a real quick example. Back when I was pedaling stepper motor drivers and servo drivers and stuff, I cannot tell you how many times somebody would come to me and their CNC router or whatever, they're like, yeah, I keep losing steps on the Z axis. And I'm like, is it losing steps where it ends up too high, or is it losing steps where it ends up too low, right? And most of them were, it's losing step and ending too low. And I'm like, there's this thing called gravity. Right?
Yep.
And none of your other axes are fighting gravity. They're fighting inertia, but they're not fighting gravity. And then they're like, well, yeah, but so I guess I just have to, buy a bigger driver and upgrade my motors. And I'm like, well, yeah, you can do that. And I'm happy to take your money. But if you just take a spring, between,
Yep. Good point.
or, if it's a really big one, you can use a gas strut, or you can use, a pulley with a weight on the other side of it, and the best one that I ever saw was the guy took the spindle motor and he put it on the back he put it on a drawer slide on the back of the gantry, and he used a flexible coupling to bring the shaft over onto the actual Z mount where he had to call it and put his bits in there, right? So the spindle motor was offsetting the weight of the Z drive. Anyway, that's just another example of people. They can only think in one thing. Oh, I need more power in the driver, as opposed to, oh, hey, maybe if I do some changes to the mechanics, I'll solve it.
Yeah.
And actually, that video that I posted of the guy that built the really good, what's she called? GLaDOS robot. It's the one that I posted in the chat. This is absolutely stunning. The voice synth alone is amazing. On that one, he found out that the 3D printed parts were too heavy for the robot arm. But looking at it, like literally a spring off of a desk lamp could have solved that problem. And, for all this guy's brilliance in other areas, he couldn't think of that.
Awesome. All right. Well, let's, I think I got a couple more here. I don't think we're going to get to them all, maybe, but let's give the next one a look here.
Hallo.
So it's funny coming from like a background in energy management that they use so many pneumatics. Matter of fact, if you go check out their website, a lot of their actuators, I mean, they have a lot of different types of actuators. They sell a lot of actuators, are pneumatic, and it's funny because they're considered in industry to be so inefficient as far as, power consumption, but how elegant they have all these different tools that, I couldn't see an obvious way around without using pneumatic air, or it just makes sense for delivery. Like that robotic arm was an amazing arm, of course.
And the
Clearly have
hand.
a really big team of of people making the things look pretty.
Have you guys noticed that like it's hard to tell if their robots are like real or rendered? Like sometimes it's obviously a 3D render like in a simulation or something, and then other times it's like I think that's a render because of the way it's labeled, and then other times it's like flying around in the atrium, or you're watching it on a table or something. You're going, is that real or is it not real? There's one frame in that video, if you go back and look for it, not now, but I'm saying if you
Yeah.
want to, the dragonfly, um, there's a piece of clear packing tape that's been used to obviously like patch a broken piece of the plastic or something. Um, and that's the only time I can remember ever seeing something on one of the robots that isn't perfect.
Mhm. Yeah, I mean, I agree with you completely. Matter of fact, so I hadn't watched this video yet. I watched the previous ones, and I'm sitting there thinking like, oh my gosh, these are amazing. But I also think, and maybe I'm just getting old and crusty, but if I was an investor, I'd be horrified. Like, where are they taking this that it's going to make me money soon? But as a person that's like that loves this sort of stuff, and somebody that might be really interested in working on this stuff, it would be an amazing place to work, it seems like. um
Yeah.
but yeah, like I'm having a hard time. Like I think it's amazing that they're doing this and that they have all this clearly a huge R&D arm of their company, but like how do they translate that to dollars and cents? Maybe that's not the right view to have about it, but it just lingers in my brain for some reason. Like, man, that's great, but how do you build this into, because you typically only see this research done in, at least maybe it's in the US, you know in schools and
Yeah.
universities.
So, so maybe think of it this way. I always kind of point to the auto racing industry, right? So a lot of the auto manufacturers have they sponsor and drive race cars. So that pushes the technology in a challenging area, and then eventually some of that technology comes back and gets productized. So I suspect in their case, they're pushing the technologies like what type of control valve or what type of algorithm or what type of actuator do we need to do this stuff. And then somewhere down the line, somebody's going to have that problem, and
Mhm.
they're going to have the expertise on hand to either build or adapt, their experimental or technology for show, basically demo technology. It shows they have the capability to do that do things in the real world others can't. And I suspect that's the business model they're using on the back end to justify this thing.
Yeah, yeah, that's fair. I know that HP Keysight Agilent, they built a lot of stuff that was, I'm very blessed to have a friend that used to work for them as an analog engineer, and he has some amazing stories that, they had a customer base where they would pay a tremendous amount of money to solve a problem, not necessarily actually build it, but solve the problem, and maybe build a prototype off of that, where they built three things. They built this
Hmm.
item, and they had three products out of it. They handed it over, and they made a tremendous amount of money doing that. I guess maybe that's also a possibility too. Like, we have this problem, solve it for us.
Yeah. Now, and I'm in aerospace at the moment, and you see a fair amount of that not so much now because it's turning privatized,
Hmm.
but you look at the old NASA things that NASA did on the initial space missions and stuff, and a lot of that stuff drives technology we have now. GPS being, a fairly obvious one, but even things like, the microelectronics and things like that. A lot of that was initially driven off of, the needs to put something in orbit or, unfortunately military as well.
Yeah.
But, it kind of it starts out in a market where you have low volume and I don't care about money attitude, right? We just got national
Mhm.
defense. It's kind of like, okay, unfortunately, money's no real
Yeah.
object per
Big
se. It's
bucks
like,
of cash.
the alternative is not acceptable, so spend what you need.
Yeah.
But in doing so, you develop the base technologies, and then you figure out how to make it cheaper, and then everybody gets it. And there's a very definite trickle down off of those advanced research projects into the general population. But it takes decades, right? And I don't think it's appreciated, in the general public where that, where a lot of the stuff we just use day to day. Again, GPS, for instance, right? GPS was a military problem, right? How do we locate our, troops and aircraft and so forth, on the field, on the planet, on the battlefield, etc. And, today everybody uses it for everything, right?
Yeah. Yeah.
But that started as a military research project. Internet, out of not DARPA.
ARPA or
ARPA, thank you, ARPA.
Hmm.
The internet we're all using right now came from a military project. And apologies for the cat.
Another thing. Yeah, you make some great points there for sure. It's and I definitely appreciate that maybe my cynicism is undue for companies paying for R&D and actually, actively pursuing it, because sometimes it feels that you see these and you're like, this is exactly what the world needs, right? The next step and the next step. And sometimes when you're the first, it doesn't mean you're the one that's profitable, although they're clearly known for it, I'm sure, in the industry. Sometimes if you're the second or third person, you can just kind of emulate without getting in trouble for the patents. You're the person that makes the money. I'm sure Alta Vista and those, are kind of like, Google, how did you win? I think we
Yeah,
have,
that's definitely the case.
yeah, for sure. I think we have at least one more video series, I think. Let me go next here. Yep. See what's going on here.
First idea was to fly the butterfly autonomously with a flying camera tracking system. Machines can work together, can speak together, and that's the idea here with the butterflies. For the technical details, we have here completely weighed, about 30 grams, included a small battery here in the back. In the front, you can see two small servo motors. Well, you have a big room. You have 10 or 15 different cameras, and all the cameras work together with a big computer technology. And the camera can fly actually 10 butterflies at the same time. All the butterflies can speak together, can work together, and we have no crashes in the air. You can see the helium baronet, and in the inside, the silver ball is a big rate. I can move the rate because in the top are two servo motors, and I can change the directions from the rate over 360 degrees. And the rest are 8 tentacles, and the tentacles are only to fly the jelly up and down. And we have here a very big lightweight constructions, about 920 grams, including the battery and all the motors. I can fly the air jelly with a very small battery over 2.5 hours, 3 hours. That's the idea from the air jelly, to show the people the energy efficiency about the movement I can say the penguin, the movement of very efficiency. I can fly here, for example, with a very small battery over 2 hours. That's the penguin for Festo.
Well, that's cool. Meat and potatoes. I really liked that they kind of went over how that jellyfish moved. I thought maybe they were moving the arms at different rates or something, but that just moving a pendulum makes more sense, I guess. Um, Still, the issue with the helium, only so much of that, but it is super cool. And I really love the noise that that jellyfish made. Like I actually really, it was very satisfying.
So I'm not that okay. I've seen things that say that the reason that the Hindenburg burned so fiercely was that they had used what is essentially rocket fuel as paint on the surface.
Hmm.
So is hydrogen really that dangerous? Certainly for something small like that, and you don't use rocket fuel for paint, I think that would be quite viable.
The trick with hydrogen is number one, it goes through everything, right? The molecules are so tiny that keeping them in something is effectively impossible, um, especially in something that's thin. So one of the reasons why they use that skin, which people argue about how big a part of the problem that was, but it may well have been like a big part of the problem. But part of the reason why they used it is because it was the metallic coating was capable of retaining the hydrogen. So that just know that that's one thing. And then the second thing is the hydrogen isn't like explosive or whatever until it mixes with oxygen. So as long as you keep it perfectly clean, nothing but hydrogen, you're good to go. But then the problem is if you do get a puncture or a hole, or if you're a hydrogen car and you get hit with something, then you have this spurt of hydrogen going out and burning, right? So they're doing all kinds of stuff like trying to capture the hydrogen in aerogel and just all kinds of other stuff to keep it from, like if there is a puncture, to keep it from escaping in a spurt like that. But it's I don't know. I think gasoline is hard to beat, and if we can make gasoline from CO2, which we can get pretty close to doing. We can make butanes and things like that. That's probably the safer way to go. Thank you for attending my TED Talk on car fuel safety.
Well, so I'm talking about for buoyancy. You could imagine a simple hydrogen generator that works chemically, and you could have one that would pump itself up and keep itself at pressure. And an item that's small, if it had a leak, well, you're right. You might have to do something to mitigate flames, because hydrogen flames are not visible, as I recall, and so
right, yeah,
flame that you couldn't tell that it was there.
Well, that's horrifying to think about. Yeah, I imagine a lot of it is just the sensationalism of the Hindenburg, and I know with my own bias thinking like, oh, isn't that incredibly explosive, right? But there's a lot of stuff out there that's explosive, right?
Yeah.
If you look at how naphtha was an anathema until it needed to be used as gasoline.
If anybody wants some really wild videos, they're really old and cheesy. They're like the old 1960s military training videos. Go look up. It's called The Man from LOX. LOX.
Oh God! Listen, you can't just tell them to go look at The Man from LOX without warning them. I mean,
let's put it this way: liquid oxygen is pretty darn nasty. I would much rather work with nitroglycerin than liquid oxygen directly.
Wow.
It's
that like 3-second clip at the end of that movie is just burned into my mind. I will never
Yeah.
disrespect locks ever.
No.
At
No,
the
I
Pacific
had no idea until I got into that and saw that, and it's like, liquid oxygen, you respect it. End of story.
Wow.
they did a demo at the Pacific Science Center routinely, I believe, where they would take a pie plate,